In our last lesson, we studied triangle congruence by side, 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 and side, angle, side postulates. In this lesson, we're going to look at two others, and those are side, angle, side, and angle, angle, side. So let's begin with postulate 4.3, which is our side, angle, side postulate. This one states, if two angles and the included side of one triangle are congruent to two angles and included side of another triangle, then the two triangles are congruent. So what this means is that if I were to take angle A and say that it's congruent to angle D, angle B and say that it is congruent to angle E, and also knowing that line segment AB is congruent to line segment DE, I now have two angles and the side that is included between them. I would have enough information for an angle, side, angle congruence. The order of the lettering, again, is very important. Angle, side, angle tells me I have an angle on each end and the side that is trapped in between them. I must have them in that order in order for it to come out as being an angle, side, angle congruence. And that's going to be true about any of the triangle congruence postulates or theorems that we work with. Now, for our first theorem based on these congruences, let's take a look at angle, angle, side. The angle, angle, side theorem, which is theorem 4.2, tells us if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. Now again, looking at this, if I know angle A is congruent to angle D, and angle C is congruent to angle F, I have two angles. Now all I need is a side that is not included between them. So if I say that AB, line segment AB, is congruent to line segment DE, I will have an angle, angle, side congruence. I cannot say that line segment AB is congruent to line segment EF, because the order that I have is the single, the double, with my side off on the side of the single. I'd have to go single, double, item on that same side. If I pick this EF to be congruent to AB, the orders are different, and so the congruence does not hold. Make sure that you put things in the order and that they are a corresponding side. This theorem does fall back partially to the third angles theorem, because since these two angles that have already been indicated have corresponding sets, according to our third angles, angle B and angle E would be congruent, and therefore we would have an angle, side, angle coming out of this theorem, but it relies on others to do that. So let's take a look at how we can do a proof based on this information. If I have the diagram as shown here, I need to prove that triangle ABC is congruent to triangle CDA. And we're going to build this in our two-column proof method. So I begin by saying that angle B is congruent to angle D, and that's a given fact. Then I know that AB, line segment, is parallel to DC, line segment. And again, that is a given fact. Because I have those two given pieces, I can conclude that angle BAC is congruent to angle DCA, which would put here and here, by alternate interior angles theorem. With those pieces, and knowing that line segment AC is congruent to line segment CA by the reflexive property, I now have two angles and a non-included side, so I can bring it over to the side and say, therefore, triangle ABC is congruent to triangle CDA by the angle-side theorem. So taking a look at the order of the problems, or order of the information, and the information that you are given, we have 4 congruence methods that we can all now fall back to in order to prove triangles are congruent. Again, proving triangles congruent is going to be a basis for moving forward and proving other shapes, but we'll start here. Make sure you have these ideas down and are ready to use them as we go forward.